Hi guys, we are back with the third part of the third unit for precalculus, which is using logarithms to solve exponential equations. It's been a while, but I hope this is somewhat useful. Okay, so first of all, let's just review what is a logarithm. And so if we're remembering, a logarithm is going to take some value, we'll say, um, we'll call that z, and another value w, and it's going to be written like this, and this is going to equal some third value, we'll say k, I'm just choosing random letters here, where basically this is another way of saying that this number to this power is equal to this number. So z to the k is equal to w. And so this is basically going to take the power of the base of something and the final number and find the power that you need to take that base to get that number. And so we're going to use them in terms of exponential functions when we're trying to figure out when the y value of that function is going to be a certain number. So let's say we have just a regular exponential equation, y equals ab to the x, right? If you're not super sure on this, you might want to review the first video we did. Yeah. And so let's say we have y equals ab to the x, and we're trying to figure out when y is going to be equal to c. And let's say, for example, c is like 1,000 people, right? It might be a word problem, might just be questionable. Let's say c is 1,000 people, right? In this case, we're going to set y equal to c, right? And so we're going to have c equals ab to the x. And then we're going to divide by a. So we have c over a is equal to b to the x. And we're just trying to solve for b. And now you'll see we have b to the x and we have a c to the a. And so what we can do is take the log base b of both sides to kind of bring the x down. Because if we're remembering, let's say we have log base b of b to the x. This is basically saying what power do we need to raise b to get b to the x? And this is just going to be equal to x. And so by putting it log base b, we just get x on one side, and then we have log base b of c over a on this side. And so we can use, so if we have actual numbers for this, I don't have numbers in this example, but if these were actual numbers, which they would be in a problem, right, from there we can just solve for x really easily just with some basic algebra. So let's do some practice. We're going to start with a problem that's kind of more abstract, just a regular equation with no like real world meaning. Let's say we have y is equal to 5 times 3 to the x. Find x when y is equal to 405. So I would say pause the video right here. See if you can try to work through it on your own, see how far you can get. If you have some trouble, that's fine. If you can figure out, that's great, but just see what you can do, come back and we'll go through it. Okay, so let's see. So y is going to be equal to 5 times 3 to the x, that's the equation, and we're trying to find x when y is equal to 405. And so if y is going to be equal to 405, then we can just put 405 instead of y here, right? And so we have 405 is equal to 5 times 3 to the x. And now we can just divide by 5, right? So we get 405 divided by 5 is equal to 3 to the x. And this is going to be the same thing as 81 is equal to 3 to the x. And so now, like we were doing before, if we take log base 3 of both sides, we're basically saying, okay, log base 3 of 81 is going to be equal to log base 3 of 3 to the x. So whatever number that you need to raise 3 to get 81 is going to be the same number that you raise 3 to get 3 to the x. And that's just going to be x, right? And so we say log base 3 of 81 is equal to x, and log base 3 of 81 is going to be 4, because 3 to the 4th is 81. And so 4 is going to be equal to x. And we can just check that really quickly. We can plug this back into the equation, right? if we say y equals 5, it's supposed to be equal sign, 5 times 3 to the 4th, right? This is going to be the same thing as saying 5 times 81, and this is going to be the same thing as 405. And so this is all correct because it equals back to the y value we started at. All right, but that was a relatively easy example, or not easy, but it was a simple example because there wasn't any really real world part of it. It was just an abstract problem, and everything was whole numbers. And so this one's going to be a little bit trickier, both because it's a real world scenario and also because we're using the e function. And so if I'm just going to put a reminder up right here, the e function is going to be equal to y is equal to p times e to the rt, or pert, is how I like to remember it. And t is going to be the replacement of x. So in here we just say x, but I like to use t. R is going to be some rate. So here it's 0.017. And then p is going to be the starting amount, and that's going to be 10,000. And so let's look at the actual problem now that we've just jotted that back into our head. The population of a town in X years is 10,000 times e to the 0.017x. In how many years will the population be 20,000? Now this one is going to follow the same general pattern, but because the equation's a little different, it's going to have the steps are going to be in a slightly different order. So see how far you can get, see if you can do it. If not, that's fine. If you can do it, that's great, but you should pause it and then come back and see what you can do. All right, let's see. So we're trying to find when the population will be 20,000. So it's going to be 20,000 is equal to y. And if we remember, the equation is going to be equal to y is equal to 10,000 times e to the 0.017x. And so we're going to say 20,000, we're going to replace that with y, is going to be equal to 10,000 times e to the 0.017x. And so now we can divide both sides by 10,000, right? And so we get 20,000 over 10,000 is equal to e to the 0.017x. And now we're going to use this logarithm notation, which I don't know if I've told you guys yet, but this is just called the natural log. This is what we use. It's a different way of writing log base e. It doesn't really mean anything. It's just an easier way of writing it because we use the natural log, the log base e, a lot in like physics or science or real world scenarios, because a lot of stuff isn't in distinct segments when it's exponentiating. It's in gradual, and so we're going to use e if we're remembering that. And so that's just ln, that stands for I don't know, it's some different language words that roughly translate into natural log, and so I'm just going to call it the natural log. But anyways, so 20,000 over 10,000, well, it's just 2, right? And so we have the natural log of 2 is equal to 0.017x. Now we're going to divide both sides by 0.017 to solve for x, and we get x is equal to the natural log of 2 over 0.017, which is going to be about 40.773. All right, there we go. Okay, now we're going to have initial value independent questions, and that's a lot of big words bunched together, and so it sounds really scary, but this is probably actually the easiest part of this section, because what this pretty much means is these questions, instead of asking, oh, when is the population going to be at 20,000, or oh, when is this thing going to have like 10 milligrams left, it asks, when is something going to have a value relative to the start amount? And so that's going to be like twice as much, half as much. So if I say the population of a town is 5,000 people, here's the equation. When will the population be double that? Right? That's going to be one of these questions. And the good thing about these is we can just ignore pretty much the first step of solving it, dividing by the initial value, because the ratio between the current amount and the starting amount is already given, right? So if I say we're trying to find when it's twice as much, we already know that the current amount is going to be 2 times that of the starting amount. And if that's my words aren't really making a lot of sense, let's look at the actual way it's written out, right? So again, if we have the normal log equation, y equals ab to the x, and y is going to be equal to twice the starting amount, for example, then y is going to be equal to 2 times a, right? Because a is the starting amount. And so we're going to have 2a is equal to ab to the x. And then if we go through all the regular steps, right, and divide by a, we're going to have 2a over a is equal to b to the x, which is clearly just 2, right? And this works with pretty much any ratio. No, this not pretty much. This works with every ratio, right? So if I say find it when it's a third as much, we're going to have to find it when b to the x is going to be equal to 1/3. If I ask when it's 5 times as much, 5 is equal to b to the x. Because the y is always going to be in terms of the starting amount, and so the ratio is always going to be whatever it's given. So if it's twice as much, it's going to be 2. If it's half as much, which is the other example we gave, it's going to be 1/2. But we'll see more examples later. But anyway, so then you can see it's just 2 equals b to the x, and so we solve it normally with a logarithm. And one more thing to note here is some of these problems are going to reference something called a half-life, which is going to be for chemicals or elements. And what that basically is if we start with some amount of that chemical or element, let's say 100 milligrams, right? How long is it going to take that element or chemical or whatever to decay enough for it to be at half, for there to be half of the amount you put in left? So in this case, it's going to be 50 grams. And so if it's asking for half-life, it's going to be with E because it's going to be a natural thing. It's going to be a constant thing, right? And so we're going to use the E equation. And then also, if it's asking for half-life, the ratio is going to be 1/2. So let's just go through some examples. Start with number 1. Bob has a savings account with 5% interest rate. How long will it take to triple? So just go through this one. Little hint before you guys start. You can use y equals ab to the x. You can also use kind of the deconstructed version of this that we went over. That was y equals p times 1 plus r to the x. Remember, these are the same thing, but we are adding the 5% interest rate to 1, just as a quick reminder, because if we are just saying take 0.05 to some power, that's going to go down, and his savings are not going to go down in this problem. But you can use either one of these, so just try to see if you can figure it out. You don't actually need the initial value, which is why it's not given. But yeah, just see if you can figure it out and then get back to me. All right, let's see. So I went for this one, right? If we have y equals a times 1 plus 0.05, because remember it's 5% interest rate. If we're asking how long it's going to take to triple, then it's going to be 3a is equal to a times 1.05, right? Because it's 3 times the starting amount. And so we divide by a, we get 3, right? And that's going to be 3 is equal to 1.05 to the x. And so if we take 1.05 if we take log base 1.05 of both sides, we get x on this side because the x just drops down like we've been over, and we get log base 1.05 of 3, which is about equal to 22.517. I should really have a about equal sign there because it's not exact, but usually 3 decimal places in this kind of stuff is good enough, at least for the math courses. Okay, so that was problem 1. So the second problem is an element decays at a rate of -3%. What is the element's half-life? So remember, this is going to be going over when it's going to be half the amount. And we're going to be using the E equation. And so the rate is going to be what E is raised to, just as a quick reminder. All right, so see if you can work through that. If you can, great. If you can't, that's okay. We'll be going over it. But yeah. Okay, so let's see. So y is going to be equal to p, because again, we don't know the starting value and we don't really need it, times e to the negative 0.03, remember, because it's percent again. So it's going to be negative 0.03 times x. And y, we're going to be looking at the half-life, so it's going to be p over 2, or p times 1/2. And so if we have p over 2 is equal to p times 0 e to the negative 0.03x, right? Because we're plugging in p divided by 2 for y. We're going to divide both sides by p. P divided by 2 divided by p is going to be 1/2, right? And so we have 1/2 is equal to e to the negative 0.03x. And so now we can take the natural log of both sides, and we get the natural log of 1/2 is going to be equal to negative 0.03x. And now to isolate the x, we just got to divide both sides by negative 0.03. So we get the natural log of 1/2 divided by negative 0.03 is equal to x. And again, that's going to be about 23.105. If you got a different answer, just go back, see if you can figure out where you tripped up on. It's also possible that you rounded differently. And so usually with a lot of these, we're going to try to not round until the very end so it's as accurate as possible. But, sometimes people accidentally round like in the middle, and it kind of messes up the rounding later on. But yeah, that was it. Yeah, so that was using logs to solve exponentials. That'll be the last part of this unit, I'm pretty sure, and the next unit is going to be on polynomials. So thank you. See you guys later, hopefully before the next 2 weeks.